Hello there. We are going to take a look at Cerebral, the Cerebral controller using Angular, because this is the good thing about how Cerebral handles state. It doesn't really matter what UI layer you have, and it doesn't really matter what model layer you have either, as long as that model layer is immutable. So what we're going to do here is check out the Cerebral package with Angular and Immutable Store. So let's move to, I have this article. I like to use Webpack when I develop my applications, so we're going to do that here. I have this article on like the ultimate Webpack setup, and we're going to use that because it has also a node server, and we're going to talk to the server in this demo application. So let me grab that one. Let's see here, paste that, and then export that into demo. Then we have to install the dependencies. After we have installed the dependencies, we are going to install the Cerebral Angular Immutable Store package. And then we're going to jump into some code and see how this works. Now, the thing is that Angular has a very set way of handling state, and it doesn't work very well. It's hard to scale Angular applications, and it's hard to understand how the application flows, like when you do changes. And sorry, that was a message from my girlfriend. It's hard to understand that flow. So what Cerebral does is give you a very precise concept on how to indicate changes in state and how you do those state changes. And we get some really good benefits from that. So let me just install Cerebral Angular Immutable Store here. And then we can fire up the application. Let's see, let's clear that and start it up. Okay, so now it bundles up the application, and let's see here, if we refresh now, we have the application running. So it just says application is loaded. It doesn't really have any code. So let's just open up the editor here. This was an old one. Let's see, open Cerebral, demo. We're going to the demo. Okay, let me just resize this a little bit. And here we go. So this is the main file, and it just logs out the application is loaded, as we saw down here. Okay. So what we're going to do now, we are going to create an Angular app. So we can do that simply by importing Angular from Angular. And we also have to import the Cerebral Angular Immutable Store. Now, the reason we just import it is that it will automatically hook onto Angular. So it just needs to be imported, and we are ready to go. So we're going to create an Angular module here called app, and it will depend on Cerebral. So let's just check to see if app is running. If this is working, but we have to hook this app up to our UI first. So let's say ng app is app, and hopefully this works. Let's see. Yeah, app is running. That is great. Okay, so where should we begin here? I think first of all we have to instantiate this Cerebral controller, and we do that using the provider. And I have this convention where I import the files into like this main file, because then I get an overview of all my components or directive components, the config and the run. So you kind of have this manifest of your Angular application. Just let me show you. So we are going to import config from config.js here. Okay, and we of course have to create that file. And this is going to export a function. And this function is going to grab the Cerebral provider. So as you probably know, Angular has its injection system, so I don't have to, well, it just magically appears. What we can do with this Cerebral provider is run two different methods. It's set default args. And what this means is that whenever you trigger a signal, you have this args object. And this args object can have some default properties, which you would set here. What's special about the Angular package is that this args object received on each signal also has access to Angular services. Specifically, the HTTP service is available, so it's easy to run HTTP requests inside your actions. We will see more on that later. I don't want to have any other default arguments here, so let me just keep that. It was just to show you. But what we have to do is set the state of the application. And this is like, if you have never heard about Flux or stuff like that, the one-way flow of the application, this might be really strange to you. But what we're going to do is put everything that is state related to our application inside this one object. And it's not a special object, it's just a plain object. Like Angular has this resource and other frameworks has similar stuff, but your date or your state is just plain JavaScript. It's objects, arrays, and strings and numbers and stuff like that. And this is actually a very, very good thing. So our application is just going to display a list of some items. So what we're going to do is first create an items object. And the reason I use an object here and not an array is because very often you get data from the server and you want to keep this data around regardless of what you're displaying in the UI. So imagine these objects as like storages for data, and then we can create the state that will actually display the items as a list. So let's call that list. And the Immutable Store project has something called mappings, and this is a really great concept because it allows you to have this single object with all the items regardless of what you're displaying in the UI, and then you can map those items to a specific list you want to display. Maybe you want to do some filtering. It doesn't matter. The good thing is that you will keep these items around, but you use other state properties to actually display them. So let's call this list mapping, and these mappings are functions. So let's create that function, and let's see here. This should return an object, and this object has a value, which is the actual state. So there's initially no difference in defining the value here and just doing what we did here. But these mappings have some extra functionality to them. So what we can do here, we can define what this state depends on, which means that whenever items change, this mapping will understand that, okay, whenever the application tries to grab this list again, I have to update myself because there's a change to the items. And what we receive here is the value, which is the array up here, and we receive the depths. So what we do here is that we just map over these values, and these values will actually be references to the items. And we're not going to use the ID, which is very typical. We are actually going to use our own ID system, which is for the front end. And the good thing about that is you no longer depend on an ID, which is only available from the server, which means that you can do optimistic updates. So when we create a new item, we will create what I call a reference. And that will be what we use to reference the item. And when we save the item to the server, we will get the ID and we will hook that ID to the item. So whenever we want to do stuff to the item related to the server, we will use the ID. But whenever we want to reference the ID in the client, in the browser or on the front end, we use this reference ID. So what we can do here, we just map over these references, and by pointing to items and the ref, we will actually return the actual item. So what we put into this state is an array of references, and what we get out of it when we use it are the actual items. And this gives us a single source of truth. So when we're going to update these items, we do it in the items map. We never do it in the list. It's just I don't know what to call it, but it's like you extract the items from this items map. Okay, so that was a lot of theory, but let's just continue here, and you will see why this is how this actually works. Okay, so now we have some state, and we have our config. So let's just check to see if this worked, and it didn't. Cerebral is not defined. What? Oh, sorry, Cerebral provider. Let's see now. And there we go. Nice. Okay, so what we're going to do now is we are going to create our first component. Now, Angular in its 2.0 version will use components, and you should really do that now with the normal Angular. So what we'll do now is change this first. I just want to make this look nice. Run from, because we're going to type in some stuff in this run file later. Let's see, run.js, and it exports a function. We're going to use Cerebral here a bit later. Okay, and now we are going to create a components folder, components, and let's create our first component. Actually, we're just going to have one component here, so okay, let's just call that app. Doesn't matter really. And this is going to be also a function, and this is going to be a directive. So I have to be honest, I don't remember all the properties here. I'm not that big of a fan of Angular, to be perfectly honest, but I have some help here from the documentation. So let's see, here we go. So this is like the recommended way of like creating components. I think it was Egghead.io, and it's it's an okay syntax, and it works pretty much like a component. So what we're going to do here, let's call it app component, and let's use app component like that. Okay, we have the controller, we have the scope, and we have Cerebral. Okay, so let's save that, and we have to create this app component HTML file. Let's just say hello, and we have to go into our main file to attach this directive. Okay, so directive should be well, I guess we have to call it app component, and then we are going to import app here. Let's see, import app from components app.js. Okay, so if I say that now, it didn't give any errors, and we should move into our index to actually start up this app component like that. And if I refresh this now, and there we have hello, great. Okay, so now this is just typical Angular stuff so far, but now we are going to create a signal, and you will see what you're able to do using Cerebral. So let's go into our app component HTML file, and we are going to, let's just wrap this in a div, and we are going to create an input here, and this is going to be an ng submit, and form submit, let's see, on form submit like that. And I think Angular prevents default here by default, so let's say it does that, and we need an input, and it's a type text, and let's see, what we want to do here is give it a value, and this value we are going to grab from our state store. So it's not inside the it's not on the scope at all, it's inside our state store. And this value, oops, it should be ng value, I suppose. We just call input value like that. We also want to react to changes to this input. That's an ng change. Oh wait, I have to use model here, sorry. Okay, so ng change, that should be on input changed like that. Like that. So let's save that, and let's see if everything worked okay. Okay, nice, we have the input. And what we're going to do now is to define this input value, and then we're going to hook up the signal. Okay, let's go into our config. Let's add input value to our state, and inside our app we are going to inject this state into the component. So the way we do that is we say Cerebral inject state onto the scope, and then we just have to define what state we want to inject, and that's the input value. So the first is the key that we want to use inside our, well, template really, and this is the path to that value inside the state store. So now we have that, and we also want to, what did I call it? On input change. On input change. We want to say Cerebral signals input changed, and we want to pass in the value. And since we have injected this value onto the scope, we can grab that value from the scope, like that. So the reason we use method names like input changed is because it will make it, first of all, it will make it easier to get a feeling or an overview of your application flow, as you will see very soon. But also, like if you would trigger an action here, if you would tell the application what to do when the input changed, like set input value, the problem with that is that you might do something else later on that action. And then this would not really make sense. So by using method names like this happened, that will never change because that will always happen. And then the action names have like, okay, do that, do this, and so on. So you'll get a better overview of this very, very soon. Okay, so let's save that now, and let's define this signal. And we do that inside run, because here we have access to Cerebral. So Cerebral signal, what did I call it? Input, did I call it just input changed? Okay, that's okay. Input changed. And what we're going to do is set the input value. That's the action we're going to trigger. And we're just going to import this from an actions file, set the input value. Now, normally you would probably have a folder with each action in its own file, because you will get a lot of them. But for simplicity's sake, we are just creating one file here, where we define these actions. So it's set input value. And this set input value action, actually all actions, will receive this args argument and a state argument. So the args argument is an object, and by default it will include the default arguments you define in the config here. We don't have any, but since you're running Angular, you will have args.services, and currently you have access to the HTTP Angular service. So you can access these on that args object, and that is really nice, especially for testing, because then you can just change that service to some kind of mock without doing anything crazy. You just pass in whatever arguments you want to the action to verify that it runs correctly. Okay, so that's the args object. And we also have this state object that has a few methods. Amongst those is set, which is a type of mutation. And what we're going to do is set a new input value in our state store, and we're going to grab the value from the signal. So inside here on input changed, we trigger the signal with an object that had a value, and this object will be merged, will be merged into this args object. So it will be available there. And if you had multiple actions chained, all of them would have access to that value property. So let's save that now and save this one. And hopefully things would change. Oops, actions. Oh, action. It should be actions. Let's see, like that. Okay, now we go there. And as you can see, now the debugger reacts to what we have done here. So when I do changes now, it triggers the signal, and it can like track it. So for example, now if I move back in time here, you see that the UI updates accordingly. And this is a really powerful concept. And if I refresh now, it will keep that state. So this is what Cerebral does. It gives you a developer experience that you're really not used to, because this kind of stuff has not been like done before in JavaScript. It exists in other languages, but this is like the really new cool thing we can do. And the reason we can do it is actually immutability. So what we're going to do now, we're going to build upon this. But let me just explain quickly the debugger here. So what we see here is the number of signals triggered. We can reset them, we can move back and forth in time, and we see the signal triggered, and we see what actions are triggered, and we see what mutations are done. So if you would jump into an application using Cerebral, you would, just playing around with the interface, you would understand the flow of the application. And if you went into the run file, like with this convention, you would have an overview of all the signals. And you can see, without actually reading the code that does the changes, you can understand how the application actually works. And that is a really powerful concept, because it's really difficult jumping into different projects, understanding how everything is connected. Okay, so let's move on here. What we want to happen is when we hit enter, we want to add this item to our items. So what we're going to do is create something which is my own kind of convention, which is called ref. So I have this next ref state, which we're going to use to set a new item when we submit it. I will go more into that. So let's see here, we have on form submit. So if let's split this up a little bit, and let's see, scope on form submit. What we want to do is, actually we can just point directly to signals form submitted. Oops, like that, because we just want to trigger the signal. The value from the input is already inside the store, so we don't have to pass that value. Okay, so now we have that signal, and then we have to define it. Let's see, Cerebral signal form submitted, and what we want to do is add the item. So let's create an action for that. Let's see, add item args state. So what we want to do first is get the value, the input value, and that will be the name of the item. And what we do is just say state get input value. And then we want to grab this reference, this next reference, and we have to use a let here because we have to next ref, because we are going to change this. Or wait, you know what? I did another demo, so I can do this a bit differently. Let's see. Yes. State get next ref, like that. Okay, so now we have the name, we have the reference, and now we're going to insert a new item. So what we do is set items. Oops. Items ref. So this is the path to the item, and then we're going to set an object here, which will have a name, which is the name, and we're also going to store the reference. And I store that with $$ on the property name, and that's because this is only related to the front end. The server doesn't care about this stuff, but the front end does. So when we have done that, we are going to create a couple of more actions, because these actions are reusable. So it's a good thing to split them up, because you can more easily reuse actions, and also you will get a better understanding of what a signal chain does. The more actions you have down the signal chain, the better understanding you get on what it actually does. So what we're going to do is increase next ref. So what we're going to do is state set next ref, state get next ref, and +1, like that. Okay, and what we're also going to do is reset input value. And now This is something you are familiar with Angular, that you can like change the state inside the controller and it's reflected in the UI. And that seems like a magical thing, but this works also here. And that's the whole idea, is that the state store should define the UI. Like the state decides what is to be displayed in the UI. And that just makes it easier to do changes. So whenever you do a change to the state, you know that the UI will be correct. So what we're going to do here is set input value to an empty string. And let's say that, okay. And now we have to get these, increase ref and reset input value. And let's add these now, increase ref, reset input value. Okay, so hopefully this works now. Let's see. And again, now you see that we still have the same state of the application. And that's a really good thing, so you don't have to reproduce it all the time. So now I should be able to hit enter. And what you saw now was that the input is empty, and we can see the signal. So we can, without implementing the UI required to like verify that it actually does the right state stuff, we can just check the signal in the debugger. So here we can see that, okay, it was, form was submitted, it set item 0, and it set a ref and a name, and we increased the ref to 1, and we changed the input value to no text. So this worked as expected. I just want to mention that if you click these states, you can see their values. So here I click the items and I could see. It's just to verify that it's like if you would push to a list, you could click it to look at the whole list, for example. Okay, but I can still move back and forth here, like you would expect. So that's basically how signals work. What we're going to take a look at now is how we can save this to the server. No, wait, maybe we should display this in the UI first. That's a good thing. Let's see, the app should also now have access to the list. So we inject that state, and hopefully I remember this Angular code. It's ling repeat item in list. Oh, what's it called? Track by index. Think that's it. And then we can say item.name here. Is that correct? Let's try to refresh. That was not right. And it's oh, sorry. Oh my god. My bad. We of course have to add the item to the list. So sorry about that. So in our action, we actually want to, when we add the item, we add this to our map, but we also want to add it to the list. And the way we do that is that we create an action that will put all the current items into that list. So you could have multiple different lists here, doing filtering and stuff like that, but we want to just display all of them. So let's just call it display list. What we're going to do here is grab the items from the state store, and what we're going to do is set the list property. And when a state inside the Immutable Store is a mapping, you always have to set a new value. So the easy way to do this is just grab the keys from the items. So the list state will only have these references as I talked about, and it will return the actual items when we use that list. So when I save that now and we make this available, and let's display the list, and there we go. We have our list item, and if I put in a new one, we can see that, and we can still move back and forth in time, and we can investigate the properties and everything here. So that's really good. Okay, so what we're going to do now is talk to the server to see how asynchronous stuff is handled. So what we're going to do is go into this server file, and we are just going to create a post here, regress, and we are going to simulate timeout here, or a delay, I mean. And what we're going to do is just return a JSON response here, and that will be an ID and just math random parse int that. Okay, so this will just return an ID as you would expect when posting stuff to the server. So let's just restart the server to make that available, and let's look into how we would do this. So first of all, we want to create a new action for this, and this action can be called save item. And what we're going to do now is do something asynchronous. So an action can be asynchronous, and the way you define an action as asynchronous, it's not on the action itself, it's how you use it in the signal. So if we jump into, to run here, and let me just change this a little bit, like that. We can, let's see, save item. We can use an array. So when you use an array with an action, it will be run as an asynchronous action, and it will receive that third argument, promise. So if I save that now, we can complete our action here. So if you're not familiar with a promise, just take my word on it. It's a great concept, and it makes it very easy to run like async actions in parallel. So let's say you wanted to save item, get some stuff, do some stuff. You could do this in parallel. So if these three actions existed, these would run in parallel, and when they were done, either one of them being rejected, like failed, or everyone was resolved, it would continue with the next action here. But we only have one action now, save item. And what we want to do here is save our item to the server. And to access the item, what we can do is in our first action here, add item, we have the possibility to add stuff to this args object. So if I return an object here, and I say that the current ref we are working on, we can return that. So it will be available to all the other actions. So if we take a look here, add item will return a ref. So all these actions actually have access to that ref. So by moving down to save item now, we can grab our item again. From state get items args.ref. So now we have the item, and we can save it to the server. What I want to also say is that when an action is run asynchronously, you can only get state. You cannot mutate state, like doing set, push, concat, and all that stuff. And that's because you really shouldn't do state changes in asynchronous actions. It has to do with the way Cerebral is able to remember your state. So I can talk a little bit more about that very soon, but let us now use one of the services here. HTTP and its post, I suppose. Items. What we're going to save is just a name. So we take a bit control here of what we're actually passing to the server, because we do not want to pass this ref property. And then we can say on success, we can actually just promise resolve. Normally you would type like this, promise resolve, and pass some data, whatever. But since the callback to success, you know what? Let me not go into this. Let me just do this traditionally. The data we will receive from the server is an object. It's an object with an ID property. So what we can do is we can just resolve the data, and that object will be merged into args and be available for the next action. And if we have an error here, data, we can say reject, but here we will define an error like that. Okay, so hopefully the Angular HTTP service converts this to JavaScript automatically. I think it does. And the thing is, as I said, you can't not do any mutations here. You can only get some data, and you can resolve or reject some value, and then you can use a new action to actually set this data. So update item ID. And now this will have access to ID on this args object, because we have it, we're passing it right here. Okay, so what we want to do is, and we also still have access to this ref. So what we can do is say state, and let's say set items args.ref, and what we want to set, oops, I did something wrong. What we want to set is the ID, and that ID should be args ID. Okay, so now we have update item ID. We have to use that one too, and we want to run that after the asynchronous action. Okay, so what happened now is that I did something in my code which caused an error. And what Cerebral does is reset the state. So if you type something wrong in your actions or whatever, and Cerebral tries to rerun signals, it will just reset the state. So I just have to reproduce it here, and if I hit enter now, see what happened, and yeah, it works. So as we can see, we have add item and display list, whatever, and we have save item, which is asynchronous, and then we run update item ID, and we can see here that, okay, it got an ID and it's been set. That's really awesome. But what's even more awesome is that even though this was asynchronous, I can still traverse back and forth in time. And that is because, and that now you see the reason why asynchronous actions can't mutate state. Because if they were to be rerun when we remember state, it would talk to the server again and would probably get an error or maybe a different ID. And we would have to lock the debugger, waiting for that server response. It's just a mess. So that is why asynchronous actions cannot mutate state. Okay, so I want to show you one small thing, and that's how I set, like I said, we have this special front-end property, but we can expand on this. We can say is saving is true, and when we update the item ID, we can say ID is saving is false. So what we've done now is we have added a property to the item which says something about the state of the item. And we could extend on this. We could give like an error property in case we were trying to save and something went wrong. We could indicate that on the item itself. So I would encourage to use these properties as much as you can, because it just gives really great control of the state inside your UI. So what I'm going to do now, I'm going to jump to app component, and let's see if I can do this correctly with templating here. I have to check the documentation again, sorry about this. Angular ngIf okay, so I can use like a span here and say ngIf item is saving, and then we can say saving like that, I suppose. Okay, let's try that. Let's try. Oh, sorry. It's me doing something wrong again. Of course, we have to merge in the changes here. I set the changes, so it removed the name, and it set only the ID and is saving, so it removed the name. But what we wanted was merge in the ID and is saving. If I change that now, and now we're back. Okay, but that's good. Let's now try to add back this span here, and we can do like that instead. Okay, so just have to refresh because it doesn't auto reload when changing these templates. And let's add foo. It says saving, and it's done saving. So that's really good. Foo bar. So my intention here was to show you how you can use these dollar properties for front-end handling, and then you just specifically send what data you want to the server. Yes, cool. So there's just one last thing I want to show you, and that is sometimes something wrong happens on the server, and you want to act upon that differently than if you successfully received like an ID in this case. So what you can do with this array is put an object as the last item. And this object has two properties, resolve and reject. And with resolve, you can, like with this array, you can add new actions. So if this save item action resolves, it will run this action. But if it's rejected, you could say update item with error, for example. It would run this action instead. And these actions does not run asynchronously, even though they are in an array. But if you would add an array here again, save item again, you could keep nesting down these paths. Though it adds complexity, so like that would mean your application is really complex, and it's really hard to handle that complexity in a good way. But I think this is better than a lot of solutions, because now you have this abstraction where you always see the flow of the application first, and then you can dive into each action to fix or change whatever you want. So if I save this now, the application should still just work as normal. And it does. Okay, So sorry about the mistakes I made. I'm not an Angular expert, but now you can see how Cerebral works and how your workflow can become when you just use these signals and you use like directive components. And that's all you need to build your application. So thanks for watching, and I'll hope you try out Cerebral.